Hey guys, so this is your second installment of your flip notes. This is on compounds and bonding. So the last flip notes we did, we ended with isotopes, and we were talking about elements and how on their valence shell they want to have a full valence shell. The last one, typically the elements we deal with in biology, is the last shell that holds 8. So they want to have 8 things in their valence shell. Compounds are made up of 2 or more atoms with their electrons, and they're in fixed proportions. That right there is the important thing about a compound. The chemical formula, so water's chemical formula is H2O, shows you the proportion. So H2O, there's 2 hydrogens and 1 oxygen. So the 2 is after the H, so that corresponds to the H. The O, there's no number there, so you assume it's 1. An atom is chemically stable when its outer orbital is filled with electrons. So that's what we just said. Some elements like helium, they're already stable. Those are the noble gases. And again, those are the ones that they don't mix with the riffraff. They already have a full valence shell. So they really wouldn't benefit from mixing or bonding or being in a compound with anything. So they don't. But most elements need to fill their shell. So to do that, they interact with other elements. Chemical bonds are the attractive forces that hold them together. So if they interact, they need to have a chemical bond to hold them together. There's 2 types, technically, of bonding. There's covalent and ionic. We're going to do covalent first. Covalent bond is a bond that forms when 2 atoms are shared. They share 1 or more pair of electrons. So if you think covalent has the CO like cooperative, think like covalent, covalent cooperative. They're sharing. If you're a cooperative team member, you share with your team. So here we have water. Water has covalent bonding. There's covalent bonds that hold water together. The important thing here is you see how the orbitals, they're overlapping. The electrons are shared between the water, in the water molecule, so between the oxygens and the hydrogens. These here are the hydrogen atoms, and the big one is the oxygen. So there's 1 electron in each hydrogen because hydrogen is 1. And remember, if you look on the periodic table, hydrogen is over here. There's 1 electron. So just remember. And then oxygen, if you count over 1, 2, 3, 4, 5, 6. So oxygen is in the 6th column. So it has 6 electrons in its valence shell. And the valence shell is the outer shell, and that's the one we care about. So 1, 2, 3, 4, 5, 6. Hydrogen, this electron, this electron, this electron, this electron. If you look down here below this, they are shared. A molecule of water, this is the 2 covalent bonds. So the electrons are being shared. Here's just another picture of that. Just take a minute, look at that. Another example of a molecule that has covalent bonds is carbon dioxide. And in class, we're going to go over these. We're going to draw the Lewis structures and show that the electrons that are actually being shared. But another important thing with a covalent bond is it actually makes a bond. So this right here, this little line, or in oxygen right here, there's a double bond. That's the purpose of a covalent bond. They're sharing the electrons so that they can make a bond. In ionic bond, the bond is formed by the electrical attraction between two oppositely charged ions. So they're not shared. They're either donated or taken. So you can look at that from two ways. You can look at that from the atom or the element that is donating the electrons, or the one that's taking it. I like to look at it from the one that's taking the electrons, because that helps you remember, like, ionic has the I, so I need them. I need the electrons. Ionic. Or you could just look at that I as being like self-centered. I need them, I'm going to take them. We're not sharing them. If you look at sodium and chloride, to make sodium chloride, the sodium, this electron, see there's 11 electrons here if you look down on the bottom, it's being transferred to the chlorine because the chlorine wants another electron. So then after the ionic bond, the sodium only has 10 electrons. So if you look down here on the bottom, it had 11. After the ionic bond, it now has 10. But the chlorine now has 18, and its valence shell is full. So the chlorine it needed the electron, it took it from the sodium. So the sodium gave it up, and the chlorine gained it. This is the same thing for potassium chloride. And you want to notice that we didn't draw this with the line and the bond forming. So if you see something written like carbon with 4 chlorines, these bonds, this is a drawing of a covalent bond. If I was to write aluminum chloride, this is ionic. So this one here is ionic. So that's a good way to tell the difference, the way they're given to you, just a hint on that. So like I said, in class we're going to go over this in way more detail. I just want you to get the basics down. So know the difference between ionic and covalent. Know what a compound is, that they're in fixed proportions. We're going to talk more about the numbers and stuff when we get into the balancing equations. But know what is the point of a chemical bond? Why do things want to be in compounds? And then what is the difference between covalent and ionic? Okay? Thank you. See you in school tomorrow.